Good morning, everybody. Happy Monday. I hope you had an awesome, restful weekend. So good news, guys. Only 2 more weeks. Okay, hang in there. Okay, we'll get this done. What I'm going to be doing these last couple of weeks, I'm going to kind of be jumping around a little bit because there are some lessons that I've got to get in before the end of the year. So today's lesson, we're going to kind of stop with what we've been doing with geometry, with surface area and everything. We pretty much did everything that we needed to with that. We're going to move into some probability stuff. Okay, so we're going to start today. This is probability of simple events. Okay, now when we talk about probability, okay, what is probability? Okay, I know we've done a little bit of this before. I think last year when you guys were in sixth grade and some of you fifth grade, probability that you've done has usually just been words, meaning like you could have had no probability, or and there's no chance. You could have had unlikely, which is probably not going to happen. You could have had equally likely. You could have had very likely or certain. Okay. What we're going to do is we're going to transition from those word types of probability, and we're going to move into actual number probability. Okay. Now the probability is basically what? The chance of something happening. Okay. And the first thing that we're going to talk about with probability is what we call the probability ratio. Okay. Now, guys, we've done a lot with ratios. Ratio means what? It means that it's a fraction. Okay. And basically, it's a comparison of two numbers. Okay. The probability ratio is a favorable outcome. In other words, what you want to happen over total possible outcomes. Okay. So let's take a look here. Okay. The first thing that we're going to do anytime we're dealing with probability, the first thing we do, step one, determine total possible outcomes. Okay. That's the first thing you're going to do every time. Okay. Because you're going to use that every time use the probability ratio in a problem. Okay. For example, everybody knows the chance of, if I flip a coin, the chance of me getting a heads, we'll say it, it's what? It's 50%, right? Or one out of two. Well, where that 50% comes from, okay, how many heads are there? There's only one. But how many possible outcomes are there on a coin? It's either heads or tails. There's nothing else it can be. Okay. So if I was flipping a coin and I said the probability of me getting a heads, the first thing I determine is the total possible outcome. Okay. The probability of getting a heads on a coin. The first thing I do is determine the total possible outcomes. Well, we know it's two. It's either heads or it's tails. Well, how many of them are heads? One. Okay, and that's where that zero point 0.5, which equals 50%, comes from. Okay, let's take a look at, let's say that we had some spinners. Okay, like those little circular things that have an arrow in the middle. Okay, if I had a spinner and I was using that to find certain probability, in this one, we've got some numbers. Okay, now we're not going to pay attention yet to what exactly the numbers are. Okay, but let's say, okay, well, first thing I'm going to do, remember, what's step one? Determine the total possible outcomes. Okay, so let's look at this. Okay, look at this thing. Remember, there's like an arrow here that, let's say we're spinning. Okay, so the first thing I'm going to do is I'm going to determine how many possible outcomes are there. Okay, well, there's one, two, three, four, five, six, seven, eight possible outcomes. Every time I spin this thing, There's 8 possibilities I can get, right? Okay. So now I'm going to use that to answer all of my questions. Let's say that I wanted to find the probability of spinning a number 2. Okay. Well, the first thing I've done, I found that I know that there are 8 possible outcomes. So I'm going to put this over 8. Okay. Regardless of what this top number is, it's always going to be over 8 for this particular problem. Okay. So if I was to spin this thing, well, remember that top number in the ratio is favorable outcomes. In other words, what we want to get is a what? A 2. How many 2s are on this board? I only see 1. So the probability of me spinning a 2 would be what? A 1 out of 8. Make sense? Okay. I can only get a 1 out of 8. I can only get a 2 on 1 of the 8 possible outcomes on this board. Okay. All right. Let's take a look at another one. Let's say I wanted you to find the probability of spinning number 1. Now, you'll notice on this board that there are what? There are more than one 1, isn't there? Okay. Well, again, what's the total number of outcomes that I have? 8. That didn't change, did it? Still 8 outcomes. Well, how many of them are 1? I've got 1 here, 2, 3. I've got 4 ones. So 4 of those 8 outcomes would be a 1. So I'm going to write this as 4 over 8, which I can then reduce. 4 over 8 reduces to what? 1/2, because each of these is divisible by 4. Okay? So the probability of me getting a 1 would be 1 out of 2, or half, or 50%, whatever way you want to look at it. Okay, for now, we're just going to express our answers as ratios. Okay, let's say I have a problem that says I want to know the probability of spinning an odd number. Okay, well, again, the total possible outcomes is going to remain 8. That doesn't change, because no matter what, there's only 8 spots on here. No matter how many times I spin it, every time I spin it, there's only 8 spots. Now let's look at all of these results and see how many of them are odd numbers. That one's odd, isn't it? So 1, 2, 3, 4, 5, 6. So 6 of these 8 numbers are odd numbers. So this could reduce to what? 3/4. So we could write it as 0.75 or 75%. Okay, I hope this is making sense. Now, there is also such thing as a probability of 0. Okay, what does that mean? Well, let's say that I wanted to find the probability of spinning a number 6. Well, regardless, I still have 8 outcomes. That doesn't matter. That doesn't change. Okay, but how many of these outcomes are a 6? None of these are a 6, are they? So this would be a 0 out of 8 chance. Okay, I still have 8 possibilities, but none of those are a 6. So this would remain a 0. Okay, which could also be expressed as 0 or 0%. Okay, right? Does that make sense? Okay, let's take a look at another one. All right, I want you to pause the video, and what's the first thing you should be doing when you look at this display? I hope that you said determine the possible number of outcomes. Okay, so let's look. Total possible outcomes. Okay, so let's look at this. How many possible outcomes are there? Well, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so I have 14 possible outcomes on this display, don't I? All right, I'm going to erase those just so they don't confuse us. 14 possible outcomes. All right, now let's say that I wanted to find the probability of a G. Okay, well, if I'm finding the probability of G, first thing, I don't care what I'm trying to find, I know that there are 14 possible outcomes, right? Okay. How many of them are a G? There's only one G up here, isn't there? So this would be 1 out of 14. Okay. Now, when you hear the word or, that typically means that either one is okay, right? If I said, um, if you spin a J or a K, you win $100. If you spin a J, do you get $100? Yes. If you spin a K, do you get $100? Yes. That means either one of those is okay. All right. So if I said the probability of spinning a J or K, okay, this means that either one of those is okay. All right. So again, the first thing I'm going to do is I'm going to determine the possible outcomes, which didn't change. It's still what? Still 14. How many J's are there? There's only one. But how many K's are there? There's still only one K. Now, but if I get a J, it's okay. Or if I get a K, it's okay. So how many total possible outcomes are there that are favorable? I put these together. So 2 of the 14 are either J or K. And then this can reduce to what? 1 over 7. Okay, does that make sense? All right, let's try this one. Let's say I want you to find the probability of, let's say, a vowel. I want to find the probability of spinning a vowel. Well, what's the first thing I do? I write the total possible outcomes. It doesn't matter what there is on the board. I know that there are 14 possible answers, possible results for this spinner. Put in drum. Okay. Now, of these 14 results, how many of them are a vowel? Well, let's take a look. Is A a vowel? Yes. So 1, 2, 3. Any more vowels? No. How many of these are vowels? 3 of these 14 are vowels. Can I reduce this at all? No. So this would be my answer. The probability of spinning a vowel on here would be 3 out of 14. Okay. Now, you can also have more than 2 probabilities. What do I mean by that? Well, let's say I wanted you to find the probability of spinning a B, D, or M. Okay? Well, is B okay? Yes. Is D okay? Yes. And is M okay? Yes. Okay? How many total possible outcomes are there? Didn't change, did it? It's still 14. How many B's are there? 1. How many D's are there? 1. How many M's? 1. So if I put these together, because any one of these is okay. If I spin a B, if I spin a D, if I spin an M, all of those are okay. So if I add those together, I once again get 3 out of 14. I hope this is making sense to you guys. It's really not that difficult. Okay, what if I said I wanted you to find the probability of spinning a T? How many T's are up here? Doesn't matter yet because there are 14 possibilities. Any one of these could be a T. However, do you see a T up here? No. So what would my probability of spinning a T be? 0. 0 out of 14. All right? Simple probability, or probability of simple events. I want you guys to, if you need to go back and watch this again, please do so. Okay? And for now, all I want you to do is leave your probability answers as a ratio. You don't have to put it into a decimal or a percent for right now. Okay? Go back and watch this as many times as you need to, guys. I hope you have an awesome, blessed day, and we'll talk to you soon. Bye-bye.